Hello. Hello, everyone. Please be seated. And the meeting is. Hello. Hello, everyone. Please be seated. The meeting is going to start.
This is the AWG Ops Area Joint Meeting. If you're not in here for that, if you could please quietly exit. Thanks.
Okay, let's get started. Hello, everyone. Welcome to the Opsawg WG and the Opsawg WG and the Ops Area meeting. And before we start, please make sure you understand those important legal issues. Basically, all your contributions to IETF, like your video, audio, draft, need to follow the important legal issues. And this is welcome to the Opsawg WG meeting first. And this is chaired by Tianran and Joe. And the blue sheet is circulating. Please write down your name so that we can get the room with right size next time. And before we really start, we need a Java scriber and a minutes taker. Is there any volunteer? Okay, Joe. Okay, thank you very much. Okay, firstly, the working group status. Right now, we have 4 active working group documents.
So the first up is MUD. The MUD manufacturer usage description document is currently in the RFC editor queue. It is pending, it is on a missing ref state pending the ratification of the ACL Yang model that's in NetMod. I spoke with Mahesh, one of the authors. That is pending one more discuss, which should clear, I'm hoping, shortly. He's provided one more update, some updated text. So we're waiting on that to go through. I'm hoping, like I said, it happens quickly. The NAT Yang model is currently in the RFC editor queue, so again, hoping that one also ratifies. The TACAX draft went through working group last call. We did get some comments that the authors are going to address with an updated draft. I'm going to act as the document shepherd for that and write it up. Again, that is the intent. There is the informational draft to describe how TACAX is currently implemented. That is being done ahead of time before a TLS or a new draft on how best to secure it. And security was the sticking point there. So maybe by 104, we'll have more substantive updates.
And we have the IPFix BGP community document. This one contains a very simple idea, and the authors resolved all the comments from the last call, and we send it to the ISG for publication. As to the AD's request, we've done an additional proofreading, and thanks Andy for the volunteer. And then we start the Opsawg WG meeting, and we have a crazy schedule. Please keep your time. Thank you. The first one is the Young Data Model for Composed VPN Service Delivery.
Hi. You'll have to excuse my voice. I'm a bit in a cold. So this is about the Young Data Model for Composed VPN service delivery. So as a recap, the service model in RFC 8309 describes a service and the parameters of the service independent of the equipment and operating environment. The service model may be divided into two following categories: the customer service model and the service delivery model. Next slide. The motivation. None of the currently defined customer service model and service delivery model discuss how to decompose end-to-end VPN service across multiple domain environment and segmented tunnel or segmented VPN service in each domain, or compose segment VPN service into one end-to-end VPN service. The composed VPN requirements have been briefly discussed, and in draft Deng Ops working group composed the VPN SM requirements. It's automate a VPN service delivery across multiple operators, and this is not practical since segmented VPN information may not be available using a single management system. So what we are trying, so the typical use case is to have one a single operators that have two domains, for example, the metro domain and the metro domain and the IP core, the IP metro and the IP core, and they are connected between each other using ASBR. And so we have a layer 2 VPN service and layer 2 VPN service from offered service portal requires coordination between two different departments in the same operator. The limitation in multi-domain VPN deployment case, customer service model, we see it there, it's too small. Network visibility to network topo in operator domain and cannot provide service decomposition in different domain through a unified interface. So the proposal is to define the composed VPN model between multiple domain orchestrators and domain controller for a single operator. Customer can order a layer 2 VPN and layer 3 VPN service separately, but operator will network visibility of end-to-end network topology have capability to manage the end-to-end service in a unified way. And the important thing is it's a single operator and not multiple operators. So the model design, we have the access point, use the service access point for connectivity service, segment between any two domains. The segment VPN, the VPN deployment information in each domain. So we have two, in this example, we have two segmented VPN, segment VPN 1 and segment VPN 2. And the composed VPN provides the end-to-end VPN deployment information across multiple domains and can be mapped into, can map from layer 3 SM to layer 2 SM with additional operational cost. So this is the model overview. In the we have a young. The composed VPN is divided into two modules. The one is the IETF composed VPN as service. This is the global parameters and essential component of a composed VPN. The IETF segment VPN, its per domain segment VPN parameters and associated access point, its parameters that are used to connect to the peer device or domain. The relation between the composed VPN and the segment VPN and access point. So a composed VPN is composed of at least one access point and at least one segment VPN. A segment VPN under segment VPN list is composed of at least one access point. So the model is access point, a segment VPN, and the composed VPN. And here's the example, and what we have emphasized there is that we see the VPN ID, the modes, and the CE mode of that. So we see that the connection between the customer, the PE and the ASBR in this model, and that's just an example. This is from the document itself. So we think this is something that we need to, in order to provide also this capability to describe the composed VPN, the end-to-end VPN, and we hope we can start to have it as an initial document to address this specific architecture of one operator and multiple domains inside the operator network. Any
Comments?
Any comments?
I see.
On the list, there was one comment which I responded, was about.
It's from this gentleman right here.
Randy Bush, IJ Anarchist. So the problems with the first document were things like inter-provider authentication, identification of endpoints. So now we just have one provider with different departments. Cost allocation, describing and provisioning with privacy constraints across the different entities, et cetera. So now we just call it one company, and that solves all these security problems.
No, we're not saying we're solving all the solution. We're saying
come back when you've solved those problems.
The question is whether we see first as the use case of having one service provider that has multiple departments. Each of them has their own management, and they want to be able to describe this solution. We understand that in order to go to a multiple domain, it's a different problem, it's a different requirement.
You've just redefined domain as multiple departments. All the problems are the same.
The difference is that each of the segment has different VPN. One is layer 2 and one is layer 3, and we connect. This is part of the models that are described in RFC 83 in RFC 83A09.
I don't think we're communicating. Excuse me.
No, I understand that.
I think, I don't want to put words in Randy's mouth. I think part of the comments, so you mentioned in, next slide, I think it was 3, you mentioned that this was discussed previously, that discussion was back in 2016 on a draft that was very, very different. To Randy's point, that was the multi SP.
Yes.
But it also was, it was a very tiny draft, and very high level, very abstracted. And the points he was raising, or he raised then, and I think, and again, not putting words in his mouth, are around how you deal with even interdepartmental security, authentication, authorization, billing. I think just putting a Yang model over some of those things and creating or redefining what a domain is doesn't necessarily address some of those shortcomings. And your request or your ask was about adoption and milestone work. I would ask the working group, how many people have read this draft? This is not the 2016 draft, and I have not seen a lot of feedback on this particular revision of it. So I would ask, is this something that the working group has read? I'm seeing one, I'm seeing two hands. I've read a few hands. I have not seen a lot of substantive discussion on this, and certainly nothing that addresses the issues that were brought up that might still be pertinent back in the 2016 version of this text.
I'm known for being inarticulate, so let me try again. The problems exist, period, when there are multiple entities, when they belong to the same corporation, whether there are multiple backbones, whether there are multiple ISPs, etc. You have authentication, privacy, etc., and those need to be covered. I'm not saying it's impossible. I'm saying it's not there.
I agree there, Anand. The question that we have on that is whether if I'm a service provider and I have a connectivity between my metro network and my core network, and I want to describe this, to be able to define just a VPN, end-to-end VPN, based on the assumption that they are connected, and they are connected by definition by the service provider, they provide this link. So the way it's going downward to do the orchestration of the different of the separate segments is part of the just goes to two different orchestrators that does this VPN definition. That's all, and that's what we expect to do in this case. I understand that if you want a more general problem, you need to address this issue. So I don't know.
Ignoring privacy, security, authentication, etc., went out of fashion in the IETF in the late 90s.
Okay.
Another comment is, I still remember this was discussed 2 years ago, and there were several concerns. One major concern is about it's very hard to identify this interface. Conceptually, the service delivery model exists, but it's easy to identify the very top service model or service interface and the very bottom device interface, but it's hard to identify an interface in between. Okay.
I'll try to look at the document and see what we can describe in for the issue of how we do the interconnect between these two parts about security and what are the assumptions there in terms of the security in order for it to be able to define this end-to-end use case.
Any other comments? Thanks, Ron.
Okay.
The next one.
I'm going to talk about SD-WAN VPN service model delivery. And this draft defines SD-WAN VPN service model. And this model is supposed to be used by service provider to provision the C devices on behalf of the enterprise customer. And SD-WAN VPN service is assumed to provide secure connection over the multiple WAN connection to simplify the management of enterprise WAN network. And this draft was initially presented in last meeting by China Telecom based on their network deployment experience. And also in last IETF meeting, ONAG, which is an enterprise community, also proposed to define the service model. So based on the ONAG service modeling and also corresponding IETF SD-WAN related jobs, we changed our jobs to adapt to more common SD-WAN definition. And here is our understanding. Although IETF has defined CE-based VPN, but it appears that SD-WAN has more functions than the defined CE-based VPN. For example, in Spring Working Group, SR for SD-WAN assumed a CE of SD-WAN could be attached to Internet or MPLS network. That is different than the previous CE-based VPN, because CE-based VPN is supposed to link only to Internet or MPLS. They have only one WAN access. And the other thing is CE can make L3 to L7 flow classification and do the steering the flow based on different SLA to different paths. And also in BAS working group, a secure layer 3 VPN has been defined, and that job specify a CPE term, because CE can offer fine granularity virtual network. That's in a VPN, there is another multi-tenant network. And apart from these things, and also security working group are working on the IE-based VPN, like advanced IPsec VPN, that's controller-based IPsec VPN. So based on our analysis, we think we propose to define the SD-WAN VPN service not only based on the CE-based VPN already defined in IETF in 4110, but also the work going on in IETF. That's the hybrid WAN connection, different path flow steering based on the SLA, and also multi-tenant separation inside WAN. So that's the draft I mentioned earlier. So here is the SD-WAN VPN service overview based on we analyzed earlier. So SD-WAN VPN service could include 2 or more sites, and each site has 1 or more CE devices, and each device could connect to 1 or more WAN network, that is MPLS network or Internet, or it could be 5G network. So that could be the case. And in each SD-WAN VPN, there could be 1 or more sub-VPN, and each sub-VPN has its own topology and policy. That is also the draft I just mentioned earlier. And layer 3 to layer 7 flow classification, and also the path steering policy. Oh, it doesn't work. Oh,
Is this one?
Previous one. Yeah, next one. Oh. Next, please.
Okay. Sure.
Oh, there is a slide update. Oh, no. Also, so that's in previous slides, I will give the overview of this, and that's the SD-WAN service we like to model we like to define. And in last meeting, ONAG also proposed the service model definition requirements to IETF. What they proposed in their slide is in an enterprise network, there could be 2 vendor SD-WAN controller. So in that way, the 2 vendor controller domain needs to be intercommunication, to provide intercommunication. And they don't want you to touch their one domain service definition, they propose to define the gateway service to provide the two different vendor domain to vendor domain reachability. That's gateway service. And the other one is the path management. Also, that means flow classification and different path selection based on different SLA. So based on our analysis earlier in the SD-WAN service model we defined earlier, and this ONAG requirements, we think we see there is a lot of commonality between these two service model, and like the connectivity service and VPN sub VPN configuration, because but they use different concept, because like ONAG use segmentation, but we here use a similar concept in layer 3 SM. So, but most things are common. So we think our model is used in the customer service side service model. That's an abstraction. So then the ONAG, they try to define the orchestrator and vendor controllers interface service model. So we think that we can use our service model to describe their service model. So that's our thought. Oh, next. And also we try to demonstrate our service modeling in ONAP. That's just for your information. And we already, that used in orchestrator facing the customer. So, next. So at this stage, we think by using our SD-WAN service model, we can use this as a basis to have the basic common understanding of SD-WAN service function. So, and based on this, we described earlier, so we like to ask whether working group likes to working on this draft and to help the SD-WAN common functionality definition. So that's the draft.
Comments on this?
Speaking without an idea here, listening to how you position this, it sounds that you have created something which you potentially have already deployed with your customers, and now you want to push that back to the owner, saying that this is the right way to do the things. Whereas from ONUG side, the agreement to work with IETF was that they will provide the requirements aggregated from their user base, and then IETF will work on the, say, suitable solutions. So this seems to be radically in the opposite direction of what was the initial plan.
Yes. So
to simplify, it seems that you are pushing your solution towards the ONUG, whereas to the ONUG, whereas they wanted to provide their requirements on what IETF should do.
I don't think we are pushing any service model to the ONAG. We just think our service model definition can provide some basis to further define the ONAG service model.
All right, so probably this needs to be taken offline to discuss in detail, but your slides imply the opposite.
Okay.
Thank you.
Okay, Charles Eckel. I've been working in MEF, and they're also very interested in SD-WAN. I guess everyone is. Within MEF, we talked with ONUG after they brought their model or their need for a Yang model into IETF. Where things kind of fell apart there was, as my understanding is from the ONAG group, what they want to do is describe everything from the point of view of an enterprise.
Yeah.
And with no involvement of the service provider.
Okay.
Whereas with MEF, our picture and our view of the SD-WAN service looks much more like what you put up on your slide.
Okay.
In that the service provider, it's a service being provided by a service provider to two different customers, which happen to be enterprises. So, and where things stand right now in MEF is there's a service definition that's nearly complete. There's just a very rough, like, skeleton of a Yang model. And so I think it might be a good idea to see about aligning not just on the picture, but maybe on the terminology, and to see if we could have one Yang model that kind of meets both use cases.
Okay, we will look at that. Okay.
I don't think it would address the ONAG use case because they're very explicitly looking for a different solution.
Yes, I'm just saying that ONAG proposed their inter-vendor domain definition, but actually, because they don't give the one domain SD-WAN functionality definition, then there is a gap between it. Because if there is no one domain VPN functionality definition, then how can you get the inter-domain functionality? So that's a gap. We think we can provide I think not the exclusive VPN components in there. We just put a common components in there to. In that way, they can use to define the ONAG service model, because they want to define that gateway service model, and they just want to define the gateway interoperability part.
I see. Okay. Right. Thank you.
Not just for this draft, and we just have something about the service models. And since this is also another service model, my question is to the AD. Is there any, I think the service model is not as usual as other device models in IETF. So for the AD, do you have any guidelines or requirement for the service models?
Well, just to clarify, what kind of requirements are you looking into that? Shall this working group work on something along those lines or not? I would say definitely yes. There is, so industry overall needs this. The question is, which way should the work be done and structured? Requirements coming from the actual users of the technology, and the work gets done based on those requirements, or taking an implementation and trying to standardize and push that to the rest of the world. The second direction seems to be not right, whereas the first one is.
Okay.
To that point, I have a couple questions, and I'll limit it and take some to the list. The one question is, to Ignis's point, what has ONAG said about what you've proposed?
Right now, we didn't get any.
Can you use a microphone?
Oh, sorry. At this stage, actually, we have our colleague, Linda Dunbar. She's also working in the ONAG. So at this stage, I just ask her to try to give our draft to let them to look at it, and whether they have other comments to add more contents in it.
Right. ONAG will have a meeting in mid-December now, and the preliminary agreement is that their requirements will be finalized by that time, and they will be provided back to the IETF.
Okay, I see. Thanks.
I'll take the rest of my comments that are contributor comments to the list. I'll let Randy finish, and then we'll move on.
Just to, Randy Bush, IJ and Arcus, just to insert confusion, and I'm not sure it's appropriate here. We have a long history of publishing documents of vendor X's or user X's implementation of Y. It doesn't have to be, it's not a standard, and if people feel that this use case and implementation is sufficiently interesting to document, but it has poor intersection with ONUG or whatever, you have this escape hatch.
That, and that goes to the questions that I'll raise on the list because we're running short of time, is I'm not certain how well your use case would, one of the things you stated early on is you wanted a generic, or you wanted to quantify SD-WAN as a thing. And I think this might be, your approach might be very specific to a use case or set of use cases and may not cover a broader SD-WAN sense. So I think maybe we need to scope this work a little bit differently, certainly in regard to other SD-WAN implementations, but maybe as well with what ONUG is doing as well.
Okay, we try to.
But
like, generalize it.
I'll email those specific questions.
Okay.
Thank you.
Yeah. The next one.
This draft is about TACUS. That's this. We try to because TACUS right now is in the publish status, and TACUS is also a very widely used widely used protocols for system management. So, and this is why we define this YAM model, because right now in RFC 17, system model only covers radius as only one centralized authentication mechanism. The system model define the authentication mechanism, including the local radius authentication and also the local authentication. But right now, this working group already defined the TACUS protocol, and is also a widely used authentication protocol. So we think it's quite useful to define a TACUS client YAM model based on the TACUS protocol to augment the current system YAM model. And this draft was initially proposed in NAT mode, and NAT mode working group suggested ours to change to this to Ops working group to work on that, because this working group provide better expertise in TACUS protocol definition. So we since last meeting we restructured our modeling based on the comments received from the NAT mode list. So for now, we define the TACUS YAM module have this structure, and it has global parameters that could be applied to servers, all the TACUS servers, and then each TACUS server could have its individual configuration parameters like server name, server IP, port, K, and single connection model. That's all be defined in protocol. And also we also add the state operational parameters here to show the connection numbers and status with the server, the client with the server. So this is the current status of this model draft. So, and in this meeting, we also received some other comments from Juniper, and they propose us to change our modeling following the system modeling radius design. So we in the next version, we like to incorporate their comments and to get update, and we'll follow the radius architecture.
That was actually going to be my contributor comment, that you seem to deviate quite a bit from what the radius system infrastructure does. At the risk of stepping in it again with TACACS, who's read this draft? Just a handful, maybe 6, like maybe. Of those who's read it, what does or in just a gut feel, what does the working group think of this work? Is it something that if we're going to ratify or document TACACS as an informational draft and maybe go further in securing it, is this worth having a model to configure TACACS on the client? Like we can do radius as an authorization or authentication, authorization, accounting. Thoughts?
Eben Harris, Juniper. So I provided comments offline on this. Pretty much every operator uses TACACS for authentication, authorization, network elements. If we leave this out, we're leaving a huge gap in the entire device configuration.
Elliot Lear. The only comment I would have is which you want to do first. Right? If you're going to go back and modify TACACS and create a TACACS v2 or a secure TACACS or whatever you want to call it, you can end up doing a lot of work here now and then end up doing a lot more work again later. And so it's just an order of operations question that I have.
Benoit Claes. So yes, it makes sense to have a Yang model for any technology. The way I try to categorize this is this like a day 1, day 0, day 1, day 2, right? The day 2 is something you can change many times, like an access list. Yes, it's something to require now. This one, TACACS, is something you need to configure a single time, right? So yes, it's good to have it, but it's priority 2.
Ignas Bogdanas. So one comment to respond to Benoit. Yes, you could typically configure that once in a lifetime of a node, but if you instantiate node every 10 seconds, that's quite often. Now, TACACS is universally deployed. Radius is also universally deployed. The use cases are different. Some deploy diameter, some might deploy something else. I think what is important is to define the IETF system extensions for authentication, authorization, accounting to have those pluggable. Then if someday we have TACACS version 2 or Radius version 27, that can be plugged into all of this architecture. So probably the more important part is to define authentication, authorization, accounting hooks into, and basically focus on the IETF system extension. Then, based on those hooks, and define the protocols.
I would say what you have up on the slide there about read and comment, I think it fits nicely into what Ignas and others have said, that as you work through this and solicit feedback, how can you evolve the system definitions for AAA as we see hopefully TACACS move forward and bring in more security. So I think my gut tells me, yes, the work is valuable. I agree with Benoit, maybe it's not immediately, but making sure that we can fully define or express this from a AAA standpoint and system is valuable. And what you learn there could be very useful for finding augmentations.
Okay.
Thank you.
Okay, next one.
All right, so I'm going to talk a little bit today about what we have going on with device onboarding at the IETF. Now, device onboarding has been going on for many years, mostly because there's always been a human, there's always been a keyboard, and there's always been a display. And with IoT, you don't have any of that. So that's the problem statement right there. So basically, I view this from the enterprise perspective. The enterprise has a bunch of questions they want to ask, in terms of the administration, under what is this thing? You have things like, what is the device's identity? Then you have some amount of accountability that needs to be framed. And then what access does it need, and is it doing what it should be doing? I'm primarily talking about the first two things today. Oops, sorry. So basic device onboarding state is you have something that comes out of the box. Device learns which network to join, and I'm thinking about this mostly from a wireless perspective because we have a bit of a fiasco dealing with wireless. And then the device is provisioned to join the network, and the network itself gets provisioned either at the same time, before, or slightly after, to trust the device, and you end up in an operational state. So a couple of design goal choices you can have. At the base, particularly in wireless, you need correct network selection to occur. If that doesn't happen, then we have big problems. Proof of ownership is a really nice feature in that process. Did the thing fall off the truck? Supply chain security, has somebody monkeyed with a device in some way? So we have this basic concept that has been developed here at the IETF, actually, which is the voucher, RFC 8366. We like this. And basically, it's a bag of bits that are well organized. And this one is based, though, primarily on the assumption that devices will both have and will be able to own certificates. So this is what Anima Bruschi uses. This is work that was done in the Anima working group, which is Draft IETF Anima Bootstrapping Key Infrastructure, otherwise known as Bruschi. And so what they've done is they say, well, we've created a workflow here where the pledge, that is, say, the end device, goes and talks to a switch, this is on wired, identifies this thing called a registrar, which some of us might call a AAA server or CA. And at some point or another, it then sends a voucher request, and the registrar forwards that along. This is done just using TCP/IP and HTTPS, and using a provisional state model. The thing then, a provisional trust model, the thing then, the registrar then forwards that off to the manufacturer, who says, oh yes, you bought that thing. Okay, so you, Mr. Registrar, I'm gonna give you a voucher that is locally significant for you. You provided me some information, I'm providing you a signature to go back with that in the form of a voucher, and that should be tunneled back to the pledge, at which point the pledge is in a position to then go to the next step, which is to then just do a normal EST transaction. So this all works pretty well in wired. We have some proof of concept code, and we've been working with a couple of vendors to prove it out. But it has a couple of issues, particularly with wireless. And so the first question that we had to address was, oh, you need IP access in order to do this, but in order to have IP access, you have to have network access. Wireless, 802.11. I know, cram it all in EAP. Well, that's exactly what we did. So we created a draft called Draft Lear EAP Bruschi, which essentially carries the same flow, but you don't need to have already authorized the device onto the network in order to do that. So it breaks the dependency loop, which is nice. And you can look. I presented this in EMU a little bit. Owen Friel and Nancy Kamwingen and I have drawn this up. It's still in early stages, and we're not yet asking for adoption because we have some questions, which is why I'm here. And the first question we have is, What if, so this model works great, assuming that there is some form of sales integration, in which case, in which the manufacturer knows that a particular registrar is meant to receive a device. But if, let's say, as I was telling my friend Dan before the break, that the Masa is a laid-back Masa and just says, sure, I'll let you join no matter who you are. This leads to a problem, which is if the device sees network A's company A's SID first, and it's meant to join company B, the wrong things happens. And not only that, but company B gets very little diagnostics out of this to know what happened. So that's bad. There's another problem, which is, well, what happens if the internet's not there? And you can't actually access the manufacturer. And these are some known problems that with the Brewski work. Now, that doesn't mean Brewski's not valuable. It's valuable for the use cases it's intending to solve, which is on autonomic computing and where you can make certain assumptions. But in an IoT world, that's not necessarily the case. So a good example might be you've got a bunch of building components that are going up prior to the internet having been installed, and maybe you have some of your network infrastructure installed, and you might want to actually have some form of transfer of ownership. So one of the problems with the IoT space is there are tons of use cases. They're scattered all over the map, and that leads to if you have order n use cases, it seems that we have order n squared solutions for them. Which is sort of bad. So one way that we were thinking about solving this problem is to essentially provide proof of ownership. This is all around proof of ownership and out of band. And if you were in the EMU working group yesterday, you heard a little bit about this, but you also heard a little bit from the EAT-NOOB people essentially describing an alternative that does the same thing. And which is nice. The idea here is that you scan in a label, you do the normal voucher request, you pass both along to the Masa, and at that point in time, the Masa can verify proof of ownership. Well, what's in the label? Maybe it's a public key, for instance, or some other identifier that the Masa will have in its registry to say, oh yes, that thing, yes, you can board that thing. And the reason you can is because you've shown me proof of ownership. Right. So then there's another approach, which is that never mind the Masa, let's just do the proof of ownership and go to the registrar, and then have the communication just between the thing and the registrar, and just let's get rid of the Masa. And this is very similar to DPP. It's very similar to EAT-NOOB. So some very common elements here across the solution space. In fact, I'm not mentioning a few other mechanisms that are around as well. The thing you lose in this case is that you have to have that label scan. You have to have done the proof of ownership, and there's no possibility of doing some sort of sales channel integration such that things just plug in and they work, which is where the Masa server really shines. So this is problematic in other regards. Okay, so I made up a little bit of a table. I want to start by saying this table is woefully incomplete. It's just the beginning. And it's an eye chart. For those people who don't like to look at the small letters on screens, all of this is posted into the Opsawg working group content thing. So what I really want to focus on in this discussion is the column here on the left. Now I think I have a pointer. Yeah, so what I tried to do, let's see here, I know I'm supposed to stay in the box, but let's see if I can do this right. So what I tried to do is find sort of things that people care about, and this is also woefully incomplete. But let's start with the base assumption, which is, do you get correct network selection? And you see a bunch of them, and this presumes, by the way, so for Anima, there's our no sales integration. So all of these, except for my doped up manufacturer, will do the job there. Can you onboard without internet access? Oops, you see, this is where Brewski sort of is painful. It finds its pain, right? Do you get proof of ownership? That is, can you tell if the device fell off the truck and is a counterfeit or is otherwise stolen? So Brewski provides for some amount of proof of sale, which is nice, but some of the other things don't. Do you get, and similarly, do you get supply chain security? They're almost the exact same question. Can you do it hands-free? That is to say, can you do this when you have sales integration? Can you just get things to plug in and work? And by the way, when we talk about wireless, what does plug in and work mean? It means round robining until you find the right network that actually has your credential, that actually knows that you're supposed to be on it. There are some shortcuts you can do in the IEEE space in this case, in where you might be able to find the right network a lot faster than going through an EAP transaction. But in enterprise, one of the nice things we like is EAP integration. And I don't talk too much about that today, and there's a reason why. Is it well secured? We have a couple of, most of the things are well secured. You'll notice I have simple serial number up there as an approach. That's for those devices where they don't think they can store 1 bit more of information through the manufacturing process. I took a small crack at status and in terms of where I thought things stood. Key type is important because you see that X509 there. Ew is what I get a reaction to from some manufacturers, or that's okay by me, by others. Again, it's a really fragmented space. You see some asymmetric cryptography in there with DPP as an example. And what's not listed here is the Enema working group has done some work on constrained vouchers, which reduce some of the complexity relating to X509. And Michael Richardson has done a lot of work on that space. So we have different varying amounts of manufacturing complexity. I did not try to go low, medium, high because everybody has their different definitions of low, medium, and high. So you have, you have to store stuff in where? Do you use public keys? Do you use certificates? Do you need back-end integration? Is there a label? Each of these has different forms of manufacturing complexities, and different manufacturers might make different decisions. And again, we're thinking about devices that range from even smaller than light bulbs to stupid little sensors, all the way up to, say, Fanuc robots, for instance, in terms of how we want to solve these onboarding problems. So, next slide. So I tried to take a stab at how I view the complexity curves on each of these. And I was again thinking in the context of Wi-Fi, right? So pretty much, if you're playing Wi-Fi, if you're doing something with Wi-Fi, your table stakes are pretty much doing something with WPA2. There are some devices that don't, but there are some table stakes there. Then there's different forms of authentication. Do you have asymmetric keys? Do you have certificates? And going along that line, it gets more and more complex. And then similarly for manufacturing, labels are at least a little bit of a pain, whereas back-end sales integration can be a major pain. Unfortunately, the curve goes the other way from a deployment complexity, so far as I can tell, which is to say, if somebody's done all that, you can plug the device in and it just works. Ain't that nice? Okay. So a couple of key observations. I'm going to augment this slide in terms of what's here. I think the key thing that I'm trying to bring across in this presentation is that we have essentially is a well-structured bag of bits in the form of this voucher. Max and Michael and Kent did a really good job actually at coming to this point. Right, this is really nice. It's a way to essentially apply an assertion into a device. It's a well-structured assertion. And that is something that I think we should be taking very seriously, because there are other elements we might want to add to it. And then both in terms of dealing with the authentication elements here, in terms of the what the device needs to get onto a network, but also maybe some additional elements in terms of how to identify that device in inventory, even if you're not using a certificate. So there's room for a lot of discussion about how to take this forward. So it's really good work. And then, of course, the other aspect of this how do you prove the assertion? And the basic means by which we're proving the assertion in Brewski, for instance, is with a signature from the manufacturer. But if you're doing proof of possession, that's not particularly that may not be particularly necessary. And so these are some things that I thought about. So I had a couple of questions here, right? Which methods should we standardize? One of the reasons I got into this is because I'm seeing a lot of fragmentation in terms of this space, and a lot of IoT-based manufacturers are saying, well, what the hell, guys? You need to help us with a little bit more guidance about what the right answers are. And so then the question is, what can they reasonably use? What sort of support matrix should we develop over time? How should we evolve all these things? And of course, I mentioned EAP-NOOB there, but I could list a half dozen other mechanisms to merge, including I want to add DPP, which brings me to another point, which is that this is a cross-standard organization question. So these are just some of the drafts. I didn't mention draft IETF Anima constrained voucher, which is also well on its way. There's also some work that Michael has done in 6TiSCH, which I haven't put on this slide, but should be paid attention to. And with that, I think I've gone as far as I need to go in this presentation. Questions, comments? And here comes Randy, who, by the way, I want you to know, Randy, you instigated part of this discussion.
Can you put your question slide up just to?
Do I have it?
One back.
Oh,
Actually, would you put slide 15 up?
yeah.
I miss the two rows, which were the two criteria I asked regarding Brisky, which is what happens to me when the manufacturer fails, and what happens to me when I want to sell that light bulb or router or whatever it is to Joe with a non-cooperative manufacturer.
Okay, so thank you for raising those 2 points. I'm sorry about that. I should have listed them, but I think there's a lot of other things I should list as well. And I think there are probably some good questions there, good answers to some of that, but they should have been listed.
Hi, I'm Steve McCann. Can you just back up to the diagram with the company A, company B?
Sure.
Whichever.
I know the one you're talking about.
That's it. Yeah. Okay.
Right, I'm
just going to talk about 82.11 for a minute, which is where I'm usually based. That's why nobody recognizes me. We've just completed some work in 82.11, which could solve some of your round robin issues about doing that initial detection of, do I want to do SSID A or SSID B? So you might want to have a look at the 82.11AQ amendment that was published in September. It also has a very lightweight version, and I say really lightweight version of MDNS over .11, but without some security constraints. So have a look at that anyway. It'll be quite interesting.
You're referring to AQ as the one with bloom filters?
Yeah.
Yeah. So yes, bloom filters provide a lightweight sort of short circuit way to find the right menu of candidate networks to join.
Yeah. Yeah, exactly. But also there's a sort of second level where you can actually start doing some very simple queries with service hashes as well. So it's not just the bloom filters, you can go to another level as well. But it's definitely worth looking at.
Steve, thank you for your comment. The key thing I wanted to bring across in this presentation is, that concerns me is what are the modes of operation for proof of possession?
Yeah, absolutely. Yeah, the .11 document doesn't cover that at all. So yeah.
Okay. Michael.
Hi, Michael Richardson. So I want to talk about the resale and the company goes away problem, Nortel. Sorry, do I say something? A little bit there. I think that important thing is, because I've bought lots of used equipment, I've tried to get firmware updates from the manufacturer for used equipment. I had long conversations with salespeople about how I didn't want to buy a new piece of equipment. I would just like to buy a service agreement to get the equipment. And I've mostly failed with most companies to ever do that. This is without Brewski. This is without any kind of stuff. So I think that there are ranges of values of equipment, from light bulbs where you simply don't bother to sell them to your friends, and whether the manufacturer wants you to resell them or not is kind of moot. The value is too low. We're not gonna get there. Then there are values of equipment where, you know what, you pay several $1 million for it, you buy it used, and damn it, the manufacturer will support you, or else you will say bad things about them. And that fact, they probably have a large amount of used, leased, etc., blah, blah, blah. And they're used to the concept that you are going to resell the device. Except tunnel boring machines apparently are left in the tunnel when you're done. They don't emerge.
Unless you're in an Ocean's 11 movie.
Yeah, I guess so. Okay. It's weird to think about all these boring machines that are under cities that are just sitting there, right? Maybe with, gigabytes of RAM in them or something. But then there's that space in between, right? How many people have picked up a Cisco 6500 15 years ago and done something useful with it, right? And Cisco didn't sell them for, I think it was 20 years since they were sold, right? And I think that is a really important question that we don't have a good answer for. But what did you do? You plugged in a serial port. You did not get automatic enrollment. You didn't expect to. You plugged in a serial port. You did the stuff, and that was it. So in that class of equipment, we're talking about, can I do it automatically or not, rather than can I do it at all? With the light bulb, there's no serial port. I guess you can get out some screwdrivers and maybe find a JTAG port, but basically you're tough, right? So there's that category that did not have anything. Without Brewski or some other enrollment process, you were screwed, you couldn't do it, period, right? And so that's a category of equipment which is different than the category of high-end equipment that you resell. And there's a space in between where there's some overlap between that, right? Can I sell my vacuum cleaner? Well, it's a couple $100 maybe. It's kind of worth reselling. Does it have a keyboard and a craft port? Probably not that I can find easily. So that is an issue, and I really think that we should address it. And I really spend a lot of time dealing with this question of us there. Fundamentally, the other part is, do I want to run a vacuum cleaner in my house with 10-year-old firmware where the manufacturer's gone out of business? I guess I can be sure it's not uploading my floor plans if the manufacturer's gone out of business, but I'm pretty sure it's going to spread dog poo all over my house. Right?
Okay.
Do I want to do that? And that's the question that is not our problem to solve, but maybe in the voucher, you actually have to have a statement that this device, and we have in MUD files, this device is still supported, and there's other stuff like that maybe it matters.
Okay, so I won't answer you point for point there, but only to say that because this is a pretty wide topic, and because I think we do have a number of questions to answer, because there are some common architectural components across all these things, one of the things I wanted to propose was to try and take it a little bit more thoughtfully in terms of finding those common architectural components and writing them down a little bit. And even if they're not common, even if we can't get the common architectural components, maybe what we can do is say, well, here are the functions that we need, sort of like that table I had up. Here's how people are solving for them, and maybe take the next step and see if we can find common architecture components in that regard. To that end, there's a side meeting right after this meeting, right here, to begin that discussion. Dan.
Thank you, Dan Harkins. On slide 4, you mentioned the steps that are involved, and
that's a rough guess. It's a rough thing. It's not necessarily in order, by the way.
Which is fine. But one of them was the device learns which network to join. And I think that if you want to do this for things, and especially if you want the things to communicate over Wi-Fi, it might be better for the network to discover the device and turn this around. In fact, if you go to the eye chart of all the columns and rows, that's basically the way DPP works, is that the person who's going to be configuring this device is the one that starts all of this stuff. And so the thing is just sitting there unprovisioned, and if you have possession of that's the way the trust works. It does have proof of ownership, by the way, but if you have possession of this device, then that's the way the trust works. If you have possession of it, you're allowed to configure it.
Yeah, so
And
I
so
should have,
there's no requirement that it has to find a network or has to round robin networks or something like that. And it's not going to get provisioned by the wrong network unless, it did fall off a truck and somebody has it now and they possess it. And, it's not quite the resurrecting duckling model. It's a little bit modified of that because the guy configuring it has to know something specific about the device, namely its public key.
right, so
And he learns that by having physical possession of it.
So I separate possession from ownership. They're slightly different, which is why you saw no there. But again, I wouldn't harp on the point. The point about whether the device initiates communication or whether the network or whether some network provisioning component initiates communication. I think there are, as I understand it, DPP is intended to actually support both models. The issue is around power consumption on the device, is, as I understand, at least one aspect of it. And the other aspect of it from a DPP standpoint is that I understand that the intent, at least, is to have multiple means by which to provision the public key into the network component.
Yes.
Yeah. So I have some understanding of that. Again, that ordering issue that you saw on the earlier slides, that is, each of these mechanisms will reorder those in some different ways. So you're right, you don't have to do a round robin with DPP. It sits there quiescent until somebody actually kicks it, right? Well, at least in the current deployment.
From the last discussion we had about this, it seemed that one of the problems was that these Brewski messages have to go to the right. They have to go to the MASA from the right. Was it the registrar?
Yes.
And if they go to the MASA from the wrong registrar, then
if you go,
it's just fail.
Yeah.
Right?
If you go to if you go to a MASA from the
we're tight on time.
Okay. Well, let's take this back to the side meeting afterwards. Okay.
We're gonna have to cut the mic line.
Before or after? A short comment, just
Okay.
to say on how these things, this is Dave Robin with representing BACnet mostly. I'm getting beaten up occasionally by customers that say they want client-only devices, and by that they mean the things never listen at all. And so in this, that's why this thing needs to, the poor little light bulb needs to initiate this, needs to find who to talk to, that kind of thing. It doesn't just sit there and wait and listen to be provisioned. So it makes it very awkward. It's so much easier if it just sits there and listens for commands. But in some cases, people don't want that. They want all ports closed, no incoming connections at all.
Right. So we'll move on. We'll talk. We'll take this up in the side meeting just after this. Okay.
Yes.
All right. So then this is the separate presentation. A bunch of people came when I first did MUD, manufacturer usage descriptions. A bunch of people came to me and said, Elliot, I sort of like the idea of having this control function and having all these access lists provisioned and what have you, but I'm not going to do that for a really long time. So what I would really like, Elliot, is if you could provide me a bandwidth profile of each of the components that are touching my network. So that's what this draft is. It's essentially how to communicate to the deployment, how much bandwidth the device is supposed to use. This draft is marked for experimental. One of the reasons is there are two reasons. First of all, it's not clear that manufacturers will be able to pull this off in terms of understanding how much bandwidth their devices are intending to use. And secondly, it's not yet clear if deployments will be able to have the right infrastructure for this. But we're starting down that path, and this is basically some experimental work that we're beginning. And so the questions really is, if we look at this order of magnitude, the problem begins to become a little bit more solvable, right? Is this thing going to generate, 100 packets per second, or is it going to be 1 packet per day, for instance? And at least order of magnitude, you don't expect a smoke detector to be generating 100 packets per second. Presumably not even if there's a fire would you expect that, which brings me to my next point. right? Which is what if there's a fire, what are the exception conditions and what happens if the device moves from nominal state to exception state? Do you see different behaviors? So we had a sort of a use case on this that we heard about, which is occupancy sensors. And here you had devices that have cameras, they do local processing, and they have a regular transactional volume. There's not really exception cases for them, and there's occasional firmware updates that will come through, but they never transmit raw video. And if you see the thing transmitting raw video, then you know that somebody's hacked the thing and is now spying on you. Okay, so I created a little bit of an extension to MUD to do this. I'm actually thinking that the extension needs to be rewritten slightly. What I've done is created new ACLs per service, and that's way wasteful. What I'm probably going to end up doing is modifying the ACL model directly and just modifying each ACE to allow for some additional information, maybe even a new container to address these points, and it'll be a little bit simpler. So as I said, current is augmenting the MUD grouping. The next one will probably augment the ACE grouping, and it will keep the files also reasonable. And what do you get out of that? You get, right now I'm looking at packets per second, bits per second, a time frame, like if I'm going to see so many packets per second over a 5-minute period, over a 5-minute burst period, or something like that. And these are sort of the parameters that I'm playing with. I think we've had one comment on the list that I should add 1 or 2 parameters, but I'm also seeking your input on this. And again, this is sort of experimental, and I think that might be my last. Oh, nope. Yeah, so I think I've covered this thing. And the key thing is it also needs to integrate with MUD abstractions, because I might want to send so many packets to my controller. So that should be the last slide, and I'm hoping to get you back on time. But are there comments on this one? Are people interested in this sort of bandwidth profiling using the MUD file? Ted?
Ted Lemon. Yeah, so I mean, I think it's interesting. The thing you didn't really talk about in a way that I understood was how you notice that, how you tell it that there's going to be a bandwidth profile for, say, firmware updates, and how you can differentiate that it's actually doing a firmware update versus just sending data.
Yeah, and I my own thinking on that one is that they'll probably use different services or different ports or different services,
different host or something,
like different hosts or something like that. But if they're not, I'm not sure I want to have indications about that on the network too much. And it's an interesting discussion point, because we want to be careful about revealing too much about the device. MUD is a reveal, there's no doubt about it, but it's a reveal with a very specific purpose. And so any reveal there has to be value to all parties if that reveal happens.
Okay.
Okay. Thanks for your time.
Elliot, real quick, one as a chair comment, you said this is experimental. Is your intent or is your hope to work on this a little bit more, get more comments, and come back and look for a working group adoption to this?
I'd like to see what people think, and I would like to collect more comments, and then have the discussion with the chairs and about what to do with it next. If there's really a big demand for this sort of thing, then we can we can really figure out how to do it well. Then we can move it from experimental into something more.
Okay, I'll reserve my contributor comments for the list. Thank you.
Next one.
Good afternoon, everyone. This is Hao Yusong. I'm going to present the updates of our draft network telemetry framework. This draft has been gone through several revisions. Right now, it's 0.1 version, but that's because we just changed the document name. Just recaps the framework. Because we believe there's for the network telemetry, we need to care about different monitoring entity and objects. Also, there have a different type of data sources that come from the control plane, data plane, or management plane. And also, for each plane, they may use a very different type of data export locations and a different type of protocols to support that. Therefore, we partition the telemetry into multiple planes and also includes the source of the external data. So for each one, it has own purpose. So for example, for the management plane, it's mainly care about the device configuration and the operation status. We already have some protocols like netconf and gRPC for that purpose. And for the control plane, it's mainly care about routing protocols and also the routing information base and the existing protocol such as BMPs for that purpose. And for the data plane, mainly care about the user traffic, right? IOM and S-flow may be used for that purpose. So we want to clarify the purpose and the scope of this draft. The first, we want to show the trend now is shifting from the conventional OEM to the streaming telemetry. And we also want to clarify several misunderstandings. Because people used to think, many people think that the management plane telemetry is all about streaming telemetry. But based on our study, we actually show it's also for control plane and the data plane. And it's also not just for the data export, right? It's also about the data generation, processing, encoding, storage, and analysis. It's a complete system. With this framework, we can map existing protocols and techniques, and also it can help us to identify challenges and gaps. And we also want to clarify that we don't mean to deprecate the conventional OEM techniques and the protocols, but to complement them and use both the old technologies and the streaming telemetry to enhance the network visibility and operation. We also acknowledge that the existing OEM protocols techniques are still evolving. They will bear more and more characteristics of the network telemetry. So what's new about this document? We have revised it based on a lot of comments and suggestions from Andrea and Randy and Uri, Daniel, Joe, and many other people. We add a new introduction section, and we add some discussion about the SNMP protocol. We acknowledge that SNMP trap notification also support have some characteristics of the network telemetry because it's allow the device to push data to the collector. And we also show added content to describe how the different planes telemetry needs some interactions between each plane, and there are also many other minor modifications. And finally, we also show what's a telemetry system will evolve from static to dynamic to interactive, and finally become closed looped to support the fully autonomous network. So the discussion is we want to discuss what we want to discuss with you is that do you believe this work is useful, and we'd like to collect feedback on what need to be modified or corrected for the content, and what else need to be included, and there's something need to be done is about the security consideration. We still need to add the content on that, and finally we'd like to call for the working group adoption.
Rob Shakir from Google. I think that this draft has, given that one of your aims is to correct some misunderstandings, has some misunderstandings itself in the draft. So I don't think that this separation between control and management plane telemetry is actually that useful or accurately reflected by the technologies. So if you look at what we're using GNMI for, we already have implementations of that are exporting LSTB state, or for example, or other control plane, what you classify as control plane status. To me, it doesn't seem useful to draw a division down that line, because you probably want to minimize the number of different interfaces out of the device. So, for example, you could replace, or you could pretty much merge your control and management plane telemetry, in my opinion. As to whether the work is useful, I think you have a uphill struggle here to make this work useful, because it's an area where there's a bunch of evolution, both inside and outside of the IETF, where for this document really to be useful as a starting point, it needs to be as up to date as possible. If we ever cut an RFC out of it, it will be immediately outdated. So I think I'm not really convinced. I think also trying to cover way too much inside of one document. You have a bunch of different discussions as to how you might build a system, as well as all of the parts of the system, as well as the intra-device implementation. I think this draft really needs some thought about whether it actually adds clarity, or whether it's actually for adding further muddying the waters of the different approaches that we have.
Yeah, so a little bit. You can mix the telemetry from different plane together in one single implementation or solution, but we believe it's clearer if you have this separation. It can help us to identify the gaps, because if you look at the existing protocols, they all cover different aspects of the network. So it's better to have a clear separation.
Unfortunately, the reality of what's being done means that that isn't the case, right? So we have the gRPC thing here, which actually I think in your draft is GNMI, which I have some vested interest in. It needs to span at least the top two. There's no reason that it couldn't span into the third one if there was data sources that way. So the reality is that there's going to be blurring between these lines, and operationally, I don't want to have n different implementations of this. So I think identifying gaps is fine. Trying to put an architectural framework around work is fine. But I think right now this draft mischaracterizes what the reality of the situation is, seeking an architectural approach that's neater, which isn't the case.
Benoit Claes, so I have to sympathize with Rob on this one, because actually I was thinking that this would be a kind of what's happening right now and showing what the future is, because in my mind the future is that, yes, you're going to have different sources. And by the way, I was confused by the terminology there. The source could be management plane or control plane or data plane, right? Sure. But in a couple of years from now, you're going to have not only 1, 2, and 3, not only 1 and 2, but also 3 sent by the same telemetry, right? Because we could be like sending active probing results via the same push mechanism. We could be sending flow record information by the same mechanism, right? So in the end, it's a single protocol that would be ideally based on Yang information, but sent by the same telemetry push mechanism. So yes, those 3, at least for exporting, will be a single telemetry protocol.
Just to follow up on this point Benoit made, sorry, Rob Shakir again. I think that's actually, if you're going to write a draft in this area, would be a useful breakdown, right? So one thing that we did when we designed GNMI is we really carefully made sure that we weren't tied to what the type of data was, and also, or how the schema of the data was expressed. So we have a single requirement for a schema that can be exported by GNMI, which is that it must have a path that can be identified by a combination or a series of elements which consist of a name and a key, or a series of keys. So if you were to write a draft that says, okay, here are the different export mechanisms we have from the device, here's what they might be useful for, here's what the characteristics of them are, then here's the data modeling approaches we have. Which of these combine? It might become clearer as to if we're aiming for this single approach from the device, which I really think is the right thing to get to in the end state. Then it might give a view of how we might get there. This is probably more forward-looking work than the kind of like current snapshot document that you're writing right now.
Kind of a chair comment. I kind of had some similar thoughts. I read through this document multiple times and thought, especially with the closed loop intent thing, that maybe there's elements of this that belong in the IRTF, that belong looking at things that haven't really been fully codified yet. The concept or the notion that was just brought up to kind of figure out what the right course of action given specific types of use cases are, or what type of data you're looking at and what exports exist, that to me makes a lot more sense. I mean, if it's more on the contributor side, but from a chair standpoint, I thought that maybe there was some potential for research areas here.
So I think although it's maybe good for the future network architecture, but it's also addressed today's network management requirements. So we think it's a well drop in the scope of this working group. And also for this plane partition, we find, especially for the data plane, it's not always rely on the data models. For example, for the IOM, it's directly use a data plane as a data source and maybe directly exports the data from the data plane. It doesn't involve any device management plane. So so from left side shows the difference between the telemetry source and monitoring entity, and with this clear partition and the mapping, I think it help us to understand the landscape of this field, and we can easily map the existing technologies into this map. So in that sense, we believe this is helpful.
Ignas Bogdanas, and you almost answered a portion of my question while I was going to ask that. It's about the requirements. A lot of work can be done, but the question of where it is applicable and what it solves. It would be interesting to get to know more about the sample and size of the samples that you did for getting the requirements. So at least which verticals, which operator groups and actual users of what you are targeting to, what's their feedback for that? Is it actually addressing real problems, or is this more of the, say, feasibility study of what can be done?
I think this addresses the real problems. In the motivation of this draft, we list several real requirements from customers, and then this framework actually, I think, help us to identify those requirements, also finds the protocol challenges and gaps, so how we can address that within IETF.
I would just say that it all depends on the sample size.
Robin from Huawei. In fact, regarding the Ignas, in fact, we talk the draft with many of the customers from the OTT and the operators. In fact, from their point, they think this is very useful because at the beginning, they always assume the telemetry is specific to a technology such as only confined to gRPC or some, but some others, they misunderstanding this the IOM and also the INT. They also called as the in-band telemetry, but also some assume that the gRPC is a telemetry. So after we give this the whole picture, they understand the whole picture and they think this is will be very helpful for them to understanding this the whole work. So that's also the motivation for us to do this work in the IETF. We think this will be helpful for the customers and the operators to understand this the whole picture of the telemetry.
Rob Shakir. I don't. I'm certain that it is useful to have more material showing what's out there and how it might combine. I would say that you probably should put together a presentation and go around operator groups presenting that. This is what we have. Putting this into a draft is going to, like, if we ever publish the RFC, it will be useless to anyone, and other than at that point in time. If you're going around and have something that's more a living document or a living presentation that shares this information, absolutely, I think it's useful.
Yeah, so I think if it's useful, now we like to actually expose to the whole entire compute community and involve everybody to contribute their ideas how we can refine this document. Yeah, we understand there's still a lot of work need to be done, and but at first if we all acknowledge this is useful, and I think at this stage we really request this to be adopted by the working group.
Yeah. Okay, Robin, and one more comment. So this additional information. So I think in fact this the much of work has been done under the guidance of this the draft. Yeah, you can see it. We have do some of the work in the IPPM working group, and also in some of this netconf. We have some of this the smart filter this the work, and also the IPRPM work. So I think this is the Euro experience. I'm not sure this OPSAWG or not like this one. For based on my experience in MPRS fields. So at the beginning, we have the MPRS requirements and the MPRS framework, so that after that, we have this much work to be done. So in fact, this is not just a summary, and also after this, the gap analysis, and also this identify the gap and the requirements, under this, the guidance, we begin to other work. So we think this is useful work.
Rob, we're gonna have to cut it. I will ask the room, who's read this draft? Why, considering what I've asked in the past, this is a substantially larger number. Of the people who've read it, do you think this is worth adopting? Is this the right work that the working group should adopt? A number of people. Are there strong objections? I know, Rob, you've strongly objected to adopting this work.
I think that if we adopt this work, it's not going. There is no chance it's going to come out with a useful outcome, and it's going to be actively harmful to the operators that are trying to understand what's out there in this space. So I would strongly object to adopting.
Ignas Bogdanas. There is valuable information in this. The format of RFC is just not suitable for this. And probably IETF is not the right place for distributing this information. Yes, you are talking about the right things. The format is not right. And well, the target audience is probably not right too. There are other industry forums which would be much, much more suitable for this.
So in essence, there's a survey-like draft, and we intend to make it, have a framework, then discuss the existing and emerging techniques and protocols. So I don't quite understand why.
I think what I'm hearing from Ignas, others, is your work. There is value in the work. It doesn't necessarily need to be ratified as an IETF document to an RFC. Myself and others, we've presented work in the past, not to be adopted, but just to bring forth to the IETF. This is the work that we're doing. Specifically, an example, the Yang catalog. Perhaps what I'm hearing is what you should do is what you've already done. You've brought this to a number of working groups. There might be, like I said, opportunity even in the NMRG to go and present your thoughts on some intent, but to go to other operators, other users groups or operator groups and spread this message as a potential different venue for this. What I'm seeing though from the room is while there are some support, it's not overwhelming. I don't think we've had a number of people who've read it. We've had some strong objections. I don't know that we can, at this point, this is work that Ops AWG can adopt. We can discuss this more on list, but it sounds like, and given that what Ignis's AD has said, this is there's probably different outlets or fora for this type of work.
So to clarify, I did not say that this work should be abandoned and forgotten. No, there's value in that, but shall this become an RFC? I don't see that.
Okay, let's discuss this in the mailing list. Okay.
Okay, next draft is in situ flow information telemetry framework. So this we called IFIT is dedicated for the data plane telemetry framework for carrier network. We see different carrier scenarios all require this data plane telemetry. From the data center interconnection to the 5G barrier network and also the access network. Because it's all multi-tenant and multi-service environment, the operator has a requirement to monitor the each user traffic's network experience and the behavior. For example, if the user traffic actually follow the designated paths defined by the service function chaining, or if the user traffic actually meets the SLA, or if there are any problems in the network, can the operator quickly identify the root cause? And finally, the operator also needs to do the path optimization to do traffic engineering and load balancing based on the real network congestion status. So this all need to do the data plane monitoring. And we already have the in-situ OEM as kind of solution which carry both the instruction and the data with the user packet. But this morning in the IPPM, we also talked about the two other alternatives. We call that postcard-based telemetry. In that, the user traffic won't carry the data, but the data collected and each node will be sent to the collector directly through some independent data packets. So each of these solutions has different trade-offs. It has its own pros and cons. But we believe it all can find its place in the data plane telemetry. So we face several challenges to deploy such kind of technologies in carrier network. The first one is the performance. Each solution may have its own performance impact. Due to the packet processing, the header instruction processing, and the header data processing. Also, the export data may be too much to overwhelm the either the export interface or the data connector servers. And also, the current solutions have very limited data flexibility and extensibility. It's just we define a limited set of data supported. Also, there are some real deployment issues. For example, for the encapsulation in IP network in MPLS, as there's no solution yet in carrier. And also in carrier, there's a different tunnels need to be supported. So in this framework, we just try to provide a solution to address all these challenges. This framework contains 4 different components. The first one is a smart flow data selection, which means we need to have an algorithm to decide which flow or which packet need to be enabled to collect the data. And the second component is export data reduction, which means we don't want to export all the raw data. Rather, we want to do some pre-processing in the data plane, and then we can efficiently compress the data and only export the subscribed data based on the event or policies to the collector. And we provide schemes to encapsulate such instruction headers in different transport protocols, such as MPLS, layer 2 network, or even IPv4 network. And we also propose a method approach to make this go through the tunnel, different carrier tunnels. And finally, we propose to use a dynamic network probe as a underlying technique to support all these three above mentioned components. So with this framework, we can support really the performance and deployability and the flexibility of the data plane telemetry solution. So the feedback we want to collect is what other challenges do you think for carrier network data plane telemetry we are facing? So if we get this, we can include this in this document. And also, we want to get big feedback on suggestions to how we can make the framework more complete. Now we are actually demonstrate the prototypes in carrier network based on this framework. And so the conceivable future work for this document is that we will include content to talk about how the data will be consumed in the application layer, and how to support the cross-domain operations. But at this stage, we also want your feedback, maybe help us to answer the first 2 questions. Thank you very much.
Comments on the questions? Who's read this draft? A few. I would say if we have a couple minutes, if there are comments. If not, I would say I would re-ask your questions on the list. You talk about carrier networks as well. Have you had this conversation with your customers or operator user groups?
Yes.
Try and you've collected some of their feedback as well?
For example, for the encapsulation and tunnels, it's a very common requirement. Today, most of our customers, they use plain IP network and also MPLS, but they find it's very hard to apply this in their network because there's no solution in IETF yet. And also the performance concern is real because they want to monitor the user traffic, but they cannot afford to lose too much forwarding performance. So the issues here are very real.
Thank you very much. I would say, again, take these questions to the list to get try to drum up more discussion and get more feedback for your work.
All right. Thank you.
And with that, that is the Ops area working group. I'll pass it over to Ignis for the final few minutes. We've got one presentation on Ops area. Blue sheets are still going around somewhere. Blue sheets are in the back of the room, maybe. If you haven't signed them, please do so. I can. Yeah. don't have your slides. I have his slides. Yes. Oh, you also loaded it?
Yes. Right. Good afternoon, everyone. This is the second part of the joint meeting. Right, next one. Thank you. So me and Warren, Warren actually is likely not here in the room because he is attending another conflicting working group, the MBOND. So now you know who loves you more. Joking, of course. And note well applies to all of this. Please sign the blue sheet if you still haven't. And we have a really short agenda this time. It's an overview of the work that is happening on a broadband forum side related to some development for models for the IPFix. And then one topic which was mostly discussed and mostly answered about the interworking of the ONUC and IETF for the SD-WAN development. So I'll spend 1 minute on that, and then the rest of the broadband forum can continue. So there is an informal agreement with the ONUC Open Network Users Group that they would aggregate and provide the requirements for the service models for the SD-WAN. Software-defined WAN. That is work in progress, and the target that they will do something by the December meeting. So we might see some more active work together with the routing working group happening on the service model development. The work that was presented might be a basis. Something might happen in parallel. It's still open question. So just a brief update of the plans. And with that, William, the stage is yours.
Yep. Oh, thanks. Yep. So thanks for the intro, Ignas. So this is IETF work, not broadband forum work, but bringing some requirements that have arisen in broadband forum. Am I doing the right thing? Am I pressing the wrong one? Oh, sorry. Okay. So there's an ID there. There's the link to the ID, and I think it's also in the materials, I think. And Ignas has kindly agreed to AD sponsor this because the IPFix working group is no longer active. So just 3 slides here. So firstly, the broadband access market has got requirements for using IPFix for transporting bulk data. So that goes beyond packet sampling, including interface, sub-interface, session statistics, and so on. Also has requirements, also meaning the broadband access market, also has requirements for using IPFix for transporting bulk data associated with other protocols. So for example, there's a BBF TR352 protocol, ICPT, interchannel transport protocol, and then so that's used in GPON2 systems for transporting dynamic data. So anyway, the point here is just that there are various requirements that Broadband Forum has. As part of sort of analyzing what should be done, because it's the usual thing, is there a model we can use or do we have to define a new one? So we've looked at the existing, we here being Broadband Forum, have looked at the existing IPFix PSAMP model, which is RFC 6728. So that's a single YANG module that performs PSAMP sampling, and everything's sort of basically in the same module, obviously. Only supports PSAMP meter and assumes support for SCTP, which is actually a bit of a problem for us. So it's actually challenging also to use this model for other IPFix applications, for example, the one I mentioned before, partly because of SCTP, which is not a requirement here. I mean, the requirement is to use TCP as the transport, which would require use of YANG deviations if using the current model. Also, I guess there are some technical issues to do with the configuration of the PSAMP meter, which I won't go into and indeed couldn't. And there is also some more general challenges. There are more of these listed in the ID, but one that I've called out here is that interfaces are referenced using the IFMIB, IF index, rather than var IETF interface's interface name. So this is really just, I mean, it's just because it's an old model. Obviously, it predates IETF interfaces. How could it? But you know, we would like the option to be able to, Broadband Forum would like the option to be able to use IETF interfaces. So in conclusion, we don't believe it's possible to meet the requirements by augmenting the existing model. We prefer to develop a new young model where the functionality is separated into different modules so that the functions can be independently leveraged. Oh, right, okay. So we have a proposed new model. Just skipping down, there are 3 modules. Two of them, there are draft versions of those included in the ID, not for the third one. So the new model adheres to the general principles of 6728, but it firstly adopts the latest Yang guidelines, which is sort of editorial, I suppose. But that is obviously, if that's done, makes it not backwards compatible from you know, right from the onset. It adds support for the 8343 interface references. It splits the model up into proposed three modules. So a base module, which is the IPFix collector and exporter functions, a PSAMP model, which is the PSAMP functions sort of configuring, sampling, metering, and then a separate bulk export, bulk data export model. It also makes SCTP optional via a feature, and probably various other features as well. And I guess I don't understand what the next bullet means, but it's transport sessions, they allow the transport session information to be retrieved individually, which I guess is not possible at the moment. Also adds some choice statements for the source and destination addresses, so that I guess there's future extensibility on how the address types that are supported. And I guess just the last bullet is an illustration of how the breaking it up into three modules, how that modularity can be leveraged. So for example, PSAMP would only use the first two, statistics would only use the first and the third, and the TR352 ICTP would only use the first. And that's it, I think.
Benoit Claes. So yeah, you're right. This is an old module. It was the first one that was done outside NetMod in the IETF. So basically, you're right with a couple of things. We should be updating that Yang module, and obviously for SCTP, obviously for the interface. By the way, we'll have to pay attention to one thing, is that in IPFix, we've got like the notion of ingress interface and egress interface, which has an extra meaning, extra semantic, because it's ingress or egress, while the IF index is like neutral. So what else? Dividing in different modules, sure, that makes sense. One for the exporter and one for the collector. So that all makes sense. It could be done pretty quickly. It's like phase one, right? And then there is a phase two, which is the IETF bulk data export. And to come back to the previous discussion about telemetry, it's yet another example of different data models going into a one telemetry protocol. In this case, it's IPFix, but we're going to see more and more of these combination of sources of data models in the future. Now, this one, we'll have to see how it's done, because we spent quite some time trying to do this with exporting MIB variables into IPFix. So in the end, we have a nice spec, very long spec, very difficult, because there are many different use cases. There are key fields. There are indices in MIB modules. Well, depending on what you're going to have, but in terms of Yang information in your bulk data export, it might become complex. But okay, phase one, phase two, and phase one is the obvious one.
I should have made it clearer. I'm sorry. Thanks, Benoit. I mean, I'm not going to respond. I don't think you're asking for a response to any of that, but thanks for that input. I just realized there's one thing I should have made clear, that, I mean, these are requirements that have come out of BBF work, but this is not BBF doing work in IETF. This is just an individual draft that happens to be authored by people from two member companies of the BBF, and the work is being done here in IETF, as you know, according to all the principles of IETF work. There's nothing special about this, except that the requirements happen to have arisen in the Broadband Forum.
Tim Carey, Nokia. So I had a question for Benoit. I didn't quite understand what you were getting at. Are you suggesting that that we take on a biz of 27 or 6728, or I was lost on what you anticipated the next step?
So the next step, you've got 3 Yang modules over there, right? The first 2, you have specified them in the draft, right? I haven't been in the details, but it's a logical step to just obsolete the old RFC. The third one, it's TBD in your draft right now. The bulk data export, right? So the content is not there. So how can we say this is the right way to go? That's why I'm thinking phase 1 and phase 2. Phase 1 for dividing the 2 Yang modules, to have a CTP as a choice, to change a naming convention, and all this, right? But I haven't seen the third one.
Okay, so but we're not talking about obsoleting any existing drafts, right? We're talking about this as just using some. This is a draft that will stand on its own, that uses principles, right? We're not talking about obsoleting any of the existing IP fixed drafts.
I think, well, right now, that is the proposal in the
this out.
draft. The proposal is that it would obsolete the 6728, which is where the current Yang model is defined.
Okay, so the expectation is it's going to obsolete 6728. That's where I was trying to understand what we're getting to. And you're saying actually looking at trying to maybe doing this so you can do it quicker in 1 or 2 steps, right? Okay,
Yeah.
now I'm sorry.
And I don't believe we need the bulk data export to replace the functionality of 6728, I believe. I believe that goes beyond, right?
One more time, please.
Well, the functionality of the bulk data export, that goes beyond 6728.
It does.
Right, so that's another good way of looking at it.
So Dave Seneca Barrickson, but I'm also the BBF IETF liaison manager. Just a clarification on the phases, because I want to make sure that there's no misconception here. My understanding from the authors is that they are planning to do, whether it's in the draft right now or not, they're planning to do all 3 of these in one phase. One
in RFC terms,
yeah.
Right.
I just want to make sure that there's no misconception that phases means like one rev, then another rev, because I mean, my understanding of their timing is they're looking to get this out sometime mid next year. So we wouldn't have time for multiple phases.
Right, but there is like phase in time. And if you write everything at the same time, this is perfect. And there is phasing like in 2 documents. And if this is an issue, we have 1 or 2 documents. I mean,
that's fine. Yeah, as long as time.
Any other comments? Thank you. So with this open microphone for the ops area, any questions, comments, suggestions, anything else?
Benoit Claes, how long do we have? 1 or 2 minutes or more, or -2?
-2, yes. We are at -3 now, exactly.
Then I'm
go
fine.
Ahead. Go ahead. Benoit, the mic is yours.
All right, so I want to come back quickly then on the service models. I guess we're going to see more and more of those service models. The issue we've been having with service models is that by the time we publish some of them, if they're not generic, they're going to be obsolete. All right. So if we believe we're going to get all the requirements from people, from operators to work on a service model, then we're going to take 6 months, a year to provide it. It's going to be too late anyway. Right. That's also why we spend some time on the catalog where we could just put the models there. And if there is some value, people will pick them up. So maybe that's one way of doing this. And where the IETF could be focusing is like maybe a generic way to do AAA, as you mentioned, right? If there are some more extension, maybe the SLA of a service, doing that with Yang, maybe a generic composition, those big items as opposed to specific service, SD1, number 1, number 2, number 3. We know it goes, right? We want a service, and then the next day we want a service +1. So maybe it's not something that even the IETF wants to do.
I'm not certain whether I have an answer for you right now for this. The overall approach of having extensibility, yes, definitely. Now, how precisely that can be done, that it is both extensible and generic enough, and at the same time it is practically usable. So again, I think you are targeting that to the SD-WAN discussion. Defining a service model for that and trying to make it generic enough to be applicable for other use cases, well, might end up in something which is unusable. Point taken, I don't have an answer, but this is something that needs to have serious thought of. Anything else? Right, thank you then.
Blue sheets?
The side meeting will commence in about 3 or 4 minutes.